Good evening, everyone. Welcome to week 8th of my lecture. Sorry. Welcome to the online discussion on course Wastewater Treatment and Recycling. So, the name of the course is Wastewater Treatment and Recycling, and the instructor is Professor Manoj Kumar Tiwari from IIT Kanpur. My name is Manetna Prakash and I am a PhD student at IIT Kanpur. So this is week 8th. So we meet every Tuesday from 7 p.m. to 9 p.m. using this Google Meet link. The link has been already been shared with you, and uh, the recording of this session is being uploaded uh, on this channel for which for the link of which has been also shared with you. So in week 8th, so if you recall the last 2 week we were in week 7 we were discussing about this secondary treatment. Before that we were discussing about just 1 minute. So in week actually from a starting, if you recall primary treatment, then secondary treatment, in all those there was one something which is called sludge. At the end of the tank we were seeing that sludge was produced, and every time we were saying that the sludge management will be how those sludge are being managed will be discussed at the end of the lectures. I mean, at the end of the treatment point. So actually we have reached at that point, that now we will be talking about how what are different terms used in sludge management, how sludge is managed, and we will be also looking onto some numerical problems. Okay, now. So if you have any kind of doubt, you can just raise your hand in between and ask any question. So the topic which has been discussed in this session are introduction to sludge management, wastewater sludge quality and characteristics, waste sludge processing and treatments. So in that also we will be discussing about sludge thickening. What is sludge thickening? Then we sludge stabilization and conditioning. So these are different process which occurs in during sludge. Then finally we will be discussing about some of the treatment process, that is dewatering, hygienisation, disposal and reuse. Whatever the sludge which is being produced after treatment, how we can after management, no treatment sludge. So there is the both in when we talk about management, it include all things treatment and reuse and all these things. So we will be looking it in details one by one. Okay. So questions are related to those topics only. So first I will discuss. Uh, so this is the background. Like if you see the preliminary treatment, we were collecting grit and all this thing. Similarly, in primary treatment, we were collecting. In primary treatment you can see that our primary tank look like this. So this was our primary sedimentation tank. Here there was this settling zone, and at the bottom of settling zone we saw that sludge are being managed. Okay. Then we have this secondary treatment, that is biological treatment, and here we also see that organic components are degraded, decomposed with the help of microbes. So we have here different, here there generally we have inorganic sludge. Amount of inorganic content is high, but here we will be seeing that sludge which is being produced has high amount of organic. Okay, now. And in upcoming slide we will be looking into advanced process. So advanced process is only starts after this secondary treatment only. So in this lecture we will be looking into this sludge processing, what is this biological, and we will be seeing that we have biological sludge that is being generated from secondary treatment, and then we have non-biological, that is high amount of inorganic, that is being generated in sedimentation tank. Okay, so I will be just taking some. I will be going through some. basic things that different terms which is used in sludge management. So first topic is this introduction to sludge management. First topic which we are which we were discussing. So coming to this introduction to sludge management. Sludge management refers to the process of handling, treating and disposing of the sludge that is generated during wastewater treatment. We have seen that generally the most high amount of sludge is generated at 2 point. That is just 1 minute. High amount of sludge are generated at 2 points. That is at primary treatment. Here we have seen that at primary treatment, then at secondary treatment. So whatever the process that is like handling is collecting it, then treating it, because we know that sludge will contain water and solid, both things. Then we have to treat, and then finally disposing. So that is known as sludge management. Sludge is a semi-solid bioproduct containing organic matter, heavy metals, nutrients, and sometimes pathogens. Effective sludge management is crucial for environmental sustainability, as untreated sludge can cause pollution, but treated can be beneficial. So we know that we have seen that in wastewater we have high organic component, and we have also seen that organic compound can be anaerobically digested to produce some methane gas, and the byproduct, the treat after production we have also something which can be utilized as a manure. So that's why we are talking about this fertilizer. Okay, now. So that's why, and if we suppose now imagine whatever the waste has been generated at you, and you left it in a open place, then obviously it will attract unwanted seeds, and normally it will cause pollution. So sludge management are included in following steps. First is thickening. That we know that we have this water plus some solid, and a huge amount of water is present. Okay, now huge amount of water and solid is there, and a huge amount of water is present in our wastewater. Okay, so first we have to reduce the water content of the sludge, and that is known as thickening. Okay, then second process is called stabilizing, the minimizing the organic content, reducing, because we know that if organic components are present, it will, and oxygen, without oxygen there will be some process, and they will start to degrade, and they will just cause some kind of odor and pathogens. So you might have seen that if waste is thrown, generally some flies and some kind of odor and all these things started to appear. So we have to reduce that thing. So that is known as stabilization. Then we have to dewatering. After stabilizing the organic content, again we have to remove more water, because when we are thickening, the process is not so much rigorous that all the water are being removed. Okay, now. So again, further removal of water content to form sludge cake. So we will be looking into what is sludge cake. Okay. Then we have disposal or reuse. Sludge may be disposed of inland, incinerated, or means it can be disposed in land, or it can be burned, or it can be reused in agriculture or construction. Okay, now. So for example, just this time I have also taken some numerical problem. Okay, so we'll be looking into one by one. Consider a wastewater treatment plant that treats 10 ki power 6 liter of wastewater per day. So the capacity of the water is 10 ki power 6 liter per day. After primary treatment, 1% of the wastewater is converted into sludge. This sludge will be needed to be before disposal. Okay, now so now just imagine they are, so 1% is converted so you can see that how 1 percentage I have taken it as a very low amount. Generally it is in 5% range. So you can see if this much amount of wastewater is coming, so this much amount of sludge, that is 10,000 liter of sludge are being produced. Okay, na. So so this is kind of numerical question. So like after thinking the stabilization process, suppose the water contains it reduced by 70%. Now we know that there was one process by which uh, then we can just look see that 70% now. If you imagine, we have gone through different process now. We have gone through some process like thickening, so it's just saying that imagine that 70% is thickened. So how much means this much amount of dewater sludge is means this much liter, if 70% out of this 70% water has been removed, then this much will again contain some sludge and it will contain some solid. Then this sludge is then dispersed of in land or landfill or in fertilizer, depending upon the treatment type of treatment which you have done. Depending upon that, this can be either disposed or can be reused. So based on this thing, I have one numerical question that a wastewater treatment plant process 5 into 20 or 6 liter of wastewater per day. During primary treatment, 2% of the wastewater volume is converted into sludge. Then the sludge initially has a solid of content 4% by weight. After dewatering, the solid content of the sludge decreases to 25%. Then we have to calculate these three things. That is volume of the sludge generated per day, and the mass of the solid in the sludge before dewatering. Okay, and the mass of dewatered sludge after the water content is removed. We have to calculate all these three things. So I will be going one by one. So in the question, it's already saying that 2% is getting converted into sludge. Then volume of the sludge will be whatever the water is coming into 0.02 into 5 5 into 10 or 5 liter, that is 10,000 liter. Then again it was saying that the sludge has initially now it's saying the sludge has initially a solid content of 4% by weight, means whatever the weight is there, 4% is solid, and after watering, solid has increased to 25%. Okay now, so we will be assuming some density, and we know the density of the water is 1 kg per liter, and the mass of the sludge is, the total mass is itna. Then since 1 liter of sludge is equal to 1 liter of kg. Okay now, so for uh, hmm. So here you can see that mass of the solid is 4% of whatever the volume has been generated. Here we have assumed that density of water and density of sludge is almost same. Okay. Then the mass of solid will be 0.04%. That mass of solid is 400 kg. Remember, if you are removing water, this mass of solid will remain constant. Okay now, in spite of the fact that how much water you remove, the mass of solid will always remain fixed. Okay now, the mass of now the if the water content is now 25%, the mass of dewatered cells can be, let m be the mass of dewatered cells, then mass of the solid is equal to 25% of the mass. We know that mass of solid will be fixed, so 4% is equal to 0.25 into m, that is m. So after dewatering, mass of the sludge was 1600 kg. I hope this is acceptable to you. This is okay. So there is similar type of question uh, in your assessment also. Okay. So coming to the next topic, that is wastewater sludge quality and characteristics. So wastewater sludge is a semi-solid material that remains after treatment of wastewater. We have already know that the quantity and the quality and the characteristics of sludge can be widely depending upon the type of wastewater, the treatment process, and the efficiency of treatment plant. Understanding the quality is crucial for proper sludge. So if you know how much sludge is coming to you and what are different characteristic, means how much organic content and inorganic, then you can manage easily whether you have to do some kind of biological treatment. Yeah, suppose if high organic compound, then you will be high organic compound is there, then you will have idea that you have to what you have to do, you have to um, treat it aerobically, anaerobically, so that you can get manure and all this thing. Okay now, and if you are treating anaerobically, you will be getting methane also. Hmm. The quality of sludge generated depends upon the several factors, including the volume of wastewater treated and the efficiency of treatment process. It is usually expressed as a volume or mass per unit of treated water. So you can remember how you can just say that whatever the amount of water which is coming into our system, depending upon the efficiency. Suppose if 10% efficiency is there, means if 90% efficiency is there, means you can just imagine there will be in all course, depending upon the efficiency we will have sludge production. Okay now, then characteristics of the sludge, this is very important because type of treatment which you have to do depend upon the characteristic of sludge. The characteristic of sludge includes its composition, solid content, density, and chemical property. These characteristics affect how the sludge should be treated and managed. So different characteristics are solid content, means how much solid is present in the sludge. The percentage of solid which indicate the concentration of solid material. Then density, the mass of the sludge per unit volume, which affect the handling and disposal method. So like if you know the density means like obviously it's not like that. Sometimes it happens that in your treatment plant we have this sludge production and we have this sludge management, but there are some time that treatment will be happening here and sludge management will be happening here. So you have to carry your sludge here, from here to here. Okay now, so if you know the density of your sludge, then how much suppose if you are using one truck and that has suppose by amount of capacity, that by liter, yeah, by kg of sludge weight it can take in one trip. Okay now, so you know already know the volume, how much volume is coming. If you know the density, you can calculate the mass, then you can just calculate that single time you have to take this much amount of, then and you suppose if three by amount of sludge has been produced, then you can say that the truck will be making three trip from here to here. Okay, yeah, you require three truck. Then chemical composition, the presence of organic matter, heavy metal, and so this is important. Like depending upon high organic matter is there, then that this sludge will be used as a manure, production of methane. Heavy metal is there, then we can extract the heavy metals and we can further do. Then we have to, like if toxic heavy metals are there, then we have to dispose it in a proper landfill. Pathogens are there. If pathogens are there, then it can spread it through water, through air. So we have to take proper care of that. Then finally, physical state of sludge ranging from liquid to solid. So this is related to solid content only. Physical, sorry, consistency, like how much solid content is there, high solid is there, low solid is there. Depending upon that, we have to manage something. Okay now. So now imagine one we have one question. So I will request everyone to solve it. Question is, the wastewater treatment plant uses a centrifuge to dewater sludge. The water generates 8 kg of sludge, 8 kg of wet sludge daily with a solid content of 4%. So 8 kg of sludge is wet sludge. Remember, water with solid content 4%. After dewatering, the solid content is reduced to 25%. Calculate the percent reduction in volume sludge due to dewatering. Assume the density of the wet sludge is approximately 1.1 kg per liter. So we have to calculate the volume reduction. Please everyone solve it. So first we will be calculating the mass of solid in the sludge. So initially 4% is there, 4% it's given. Then the mass of solid is 4% of 8,000 kg. Then the mass of solid will be 0.004 into 8,000 kg, that is 320 kg. Then density already given. Then with the help of density we will be calculating also the volume. In volume of sludge is equal to mass of the wet sludge by density. Then the total volume of the wet sludge is equal to 7272.73 liters. Okay. Then final content. So and if you remember, we have already said that whatever the water is being removed, solid content will be always fixed. That is, whatever the solid there from starting to end, that amount of solid will be there. So final solid content is 25%. The mass of deep water is equal to mass of solid by mass of solid content, that is 320 divided by 0.25. The mass of deep water is 1280. Okay now. Assuming the dewater sludge, again remember, density I have given you of wet sludge, but remember that um, we can also assume the density of dewater sludge, and here I have taken 1.2 kg. Okay now, the mass of dewater sludge will be this much is dewater sludge, then this much volume we will be getting. Then percentage reduction will be initial value minus final value divided by initial value. Initial volume, how much water was there, and how much volume of the wet sludge was there, 7272, and final volume of the water is 1066.67. Initial value is, then by putting it we can see that the percentage reduction is 85%. Okay now. So here I will be adding one more term. Okay, I hope this is question is clear to you. Then coming to the third option, that is wastewater sludge process and treatment, or sludge thickening. Then sludge thickening is the process used to reduce the volume of the sludge by increasing its solid content. The step is crucial for the treatment of disposal at it helps to decrease the cost associated with handling and treating large volume of water. The primary goal is to reduce the water content in the sludge, making it more manageable. Okay, so I think this is self-explanatory. Then there are different method of sludge thickening, that is gravity thickening. Then you utilize gravity to settle out the sludge particles from the sludge, concentrating them at the wet end, at the bottom. So we have this type of a structure, and what will happen that sludge are kept here. So with time what will happen that all the solid particle will get settled here. Okay, and at the topmost layer we will have water, then this water can be removed, and then we have thickened sludge. Okay, then dissolve air filtration, use air bubble to float the solid to the surface, and then can be, then other process is that there will be this type of equipment arrangement, there will be perfocation. As we know that those solids are very light in weight, the sludge the solid which is there, and its amount is very less, 4%, 2%, 4%, 2% is there. And what will have happen that we will pass air through these holes. So what will happen that all the wastewater which is there will start coming at the top, and we can remove those solid. Okay, then we have rotary drum thickening. Then enjoy the rotating drum with a filter to separate the solids and liquid. Again, this is a drum type of rotating things will be there. Sludge will be kept here. So what will happen that the solid, there is some arrangement, you can just type on net and you can find out what is the rotary drum thickening. Again, we have one question related to that topic only, that sludge thickening system is to design operate a flow of 50 liter per minute. The system operates for 24 hours. The sludge entering the system has a solid content of 2% and leave with the solid content of 10%. Okay. Calculate the total mass of solid entering each day and the total mass of solid leaving the system each day. Determine the mass of solid obtained by system each day. So you have to calculate three type of mass. Okay. Here also you can assume the previous density if you have to assume any kind of density. If you have to assume any kind of density, you can assume the data from the previous question. Okay, so I will give you. Hmm. So here you can see the flow rate was 50 liter per minute and it is operating for 24 hours. Then we can calculate the total volume. The total volume comes out to be 72,000 liter per day. So here it is saying that calculate the mass of solid and we know the solid content is 2%. So whatever volume of the 2% is solid. So this much solid is coming in the system. Solid content leaving is 10%. Okay na? So so whatever the solid is leaving is 10% of the volume entering. So that is 72,000 kg is leaving. The mass of the solid removed from the system. So this much mass is being removed. Okay. So this is a very easy question. I hope this is okay to you. Then finally we have wastewater sludge processing, treatment, sludge stabilization and conditioning. So there is two process of actually less number of people are there, so I don't know if you have any kind. Wastewater sludge processing and treatment, sludge stabilization and conditioning. Okay, so this is like sludge stabilization is the process of reducing the potential for sludge to decompose and produce odor of harmful gases. So that's why we know that if the sludge is there, then organic component which is there, once the free oxygen is consumed, then it will start acting on other. It will start either it will start dying or it will start acting, or anaerobic condition will dominate and it will start producing foul smell. Okay now, this step ensure that the sludge is likely to undergo uh, putrefaction and is safer to handle, store and dispose of. The stabilization also helps in reducing the volume of sludge and improving its dewatering properties. So there are different methods of sludge stabilization. First is anaerobic digestion. Uses microorganisms in presence of oxygen to break down organic matter. Then we have anaerobic digestion. Uses microorganisms in the absence of oxygen to decompose organic matter and producing biogas. And then we have lime stabilization. Adding lime to the sludge to increase the pH, which helps in pathogen destruction and stabilization. So we know that mainly the pathogens are responsible for producing these kind of pollution or to cause some kind of disease and all these things. So that's why lime is used. Okay, then second option is sludge conditioning. Sludge conditioning is enhance the physical and chemical properties of sludge to improve its dewatering performance. So these are different process by which we can improve, by we can do the sludge handling and all these things. Okay now, so conditioning makes the sludge more amenable to process like centrifugation, filtration, and processing. Chemical conditioning add chemicals to improve the flocculation. So what happened that if we want to, if we want to settle our solid present in our sludge, then we will be adding some chemicals, and with time it will just settle down. Okay, now physical method to alter like heat or ultrasound. Just we can do anything. Then we have biological conditioning, employ microorganisms to enhance the dewatering process. Somehow we have to remove the water. Okay, now again we have one question related to that topic. A wastewater treatment plant process itna kg of sludge daily with an initial solid content of 2% by weight. So in this volume 2% each our solid. The plant utilize lime to condition the sludge, which increase the solid content to 6%. The lime which is used has reduce the increase the solid content to 6%. Remember, amount of solid is fixed. If solid content is increasing, remember the water is going away from our system. Nothing is happening to our solid. The lime addition process is desired to improve the dewatering efficiency by reducing the volume of sludge by 60%. Now remember, whatever the volume is coming, 60% is reducing the volume, and only the volume of water is being reduced. Means how miss, we know that means water is only going from the system because you know that we don't want to throw our solid. If some efficiencies there, like some system, we are assuming that system is working 100% efficiently, means all the sludge are system. If suppose there is like system is working 90%, then only 90% of solid is remaining in our system. If the density of the conditioned sludge is approximately 1.3 kg per liter, calculate the final volume of conditioned sludge produced daily and the mass of the lime added if 10 kg of the sludge is produced to condition 1000 kg of the sludge. Okay, so calculating the initial volume, that is 2% of whatever the volume is coming, then 1000 kg and be remember remember how we are calculating this mass kg, because we are assuming that for sludge which is coming has a density of 1 only. Okay now, then the calculate the mass of the water. The final volume content is 6%. The mass of the dewater is mass of solid by solid content, that is mass of dewater sludge is 100 kg. Then 6%, that is this much will be mass of the dewater sludge. Okay. Then the density of the conditioned sludge is 1.3 kg. Then the volume of dewater sludge is equal to mass of the dewater sludge by density. Then the volume of dewater sludge will be this much, that is this much liter. Okay now we have to calculate this lime and this thing also, lime to be added and all this thing. Initial volume is 5000 liter, reduction in volume is 60,000. Then final volume will be 100 minus 60 into initial volume, that is 20,000 liters. Okay, the final volume based on the dewatering should match the calculated volume of the, considering the potential process variation. Lime required is 100 kg per 1000 liter, and the total volume of sludge condition is 50,000. So what is the amount of lime to be added? That is 500 kg. Okay, coming to the final topic, that is wastewater sludge process and treatment, dewatering, hygienisation and disposal and reuse. Okay now, so dewatering is the process of removing excess water from sludge to reduce its volume and making it easier because we know that I have told you that I have to carry our sludge from one location to another location. That's why we have to do this dewatering and all. The main goal is to increase the solid content of the sludge. The common method includes centrifugation, belt process, filter press, and a screw press. Centrifugation is like this kind of setup. There will be rotation, and our this will the solid will get settled here. Okay, then we have belt press. Like what will happen, that there will be one rotating facility, then there will be this belt will be passing over this, and sludge will be passed through in between those. So as it is pressing, the water will escape from the system, and the sludge will get collected at another end. So okay, then again we have filter press, then a screw press. These are some kind of mechanical mechanism via which we can reduce water. Then we have another process known as hygienisation. Hygienisation involves the treating of sludge to eliminate the pathogens and reduce health risks. Use high temperature to kill pathogens. Hello Subhas. So again coming to this hygienisation process. Hygienisation involves treating the sludge to eliminate the pathogens and reduce the common health. The common method are treatment, thermal treatment, then chemical treatment, then composting. So thermal treatment by meaning we can understood that it is uses high temperature to kill pathogens, and chemical treatment we will be just we want to maintain a some kind of what do we call it as a uh, hygiene. We want to maintain a hygiene in our because because we have to handle it somehow, and we don't want any kind of pollution or odor coming from our sludge. Okay, then composting we have already discussed it. Then finally disposal or reuse. Once treated sludge can be either disposed or reused. Common disposal method: landfill disposal, incineration. That is landfill, like we know that suppose a um, or suppose some amount of sludge is being produced, so a dedicated landfills are always in a area, and what will happen that we will dispose our sludge in the this landfill. Then incineration, suppose remember all these process depend upon whether these are economically feasible or not. It's not like that there is always process to burn everything, but we cannot burn everything because that will simply not economical. So whether by disposing it will be economical, or whether by burning it, or by application agriculture means either by turning into fertilizer it will be economical to us or not. So we are always looking into economical perspective, where we have to spend minimum, yeah, or if we getting something back from that. Okay now, so if you have paid attention, so like we know that if organic content is there, uh, we will be converting into this agricultural waste, agriculture fertilizer. Now heavy metals is there, toxic heavy metals are there, then we will be disposing into landfill. And now suppose something is some that amount of that will be giving high amount of means that does not require high amount of energy to burn, and that cannot be put in landfill also, then we can just burn it. So there is always one option. So a question related to this, I request you to solve it. Assume any kind how many. Try to solve this question. A plant dispose this much liter of dewater sludged by land application. If the sludge has a solid content of 10% and each hectare of land can accommodate 50 tons of sludge, determine how many hectare of lands are needed. Assume any value. If you think that if any data is required, I request you to assume it. Just when you are answering it, that just write it down like what you have assumed. And or you can see that in my during my solution what I have assumed, and by putting those value are you getting same answer or not. was so coming to this solution of this question. So it say that solid content is 10% and volume is 3000 liters. So the mass of the solid will be 10% of this much liter. So here what I have assumed that density I have assumed as 1 kg per liter. Okay now, so that's why you can see that I am writing liter into kg. Okay, this much into this much kg. This is our assumption. I hope you are understanding it. Assumption is 1 kg per liter density. So you can see the mass of the solid is 3000 kg, and each hectare can accommodate 50 ton of kg, and total mass is 3 ton. So the land required is only 0.2 ton. I hope this was very easy question. Next question is also related to next question is little bit combination. So as if you have any kind of doubt, you can ask related to any topic. Do you have any doubt? Right now we are discussing this thing. Only 2% are there, so you can ask it. No problem. I won't mind. Subhas. Yes, should I continue? Try to solve this question. A wastewater treatment plant is considering upgrading its sludge dewatering system. Currently, the plant generates this much liter of sludge daily with the solid content of 2%. The new system will increase the solid content to 7%, but also increase the operational cost by. Okay. Okay, just I will explain why a simple question. So this is the most simple. So we were discussing like this thing only, that in primary treatment and in secondary treatment we have this sludge production. Okay, now. So we will be looking how these sludge are produced, how these sludge are managed. So uh, 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 huh. So sludge and we know that sludge is nothing but a semi solid bioproduct containing organic matter. Means semi-solid means you know that there will be water and there will be some solid. So and huge amount of water will be there. Okay, now density of the sludge generally vary between 1 to 1.5. You will be seeing. Okay, now we will be seeing some numerical question, and if not generally means one between 1 and 1.5. Okay. During management we have to we know that our final aim is to get some bioproduct. Okay now, so to get that bioproduct, what we do that there are different process, like we have to manage it. Either we can throw in landfill. So first we have to remove that water. So to remove that water, there are different facility which we will be looking. Or what we can, and once the water is removed, the whatever solid is remaining, we can either dispose it, or either we can do many things. Okay now. So different process to remove the different process that is in sludge management is, first we is known as thickening. So initially we know that a huge amount of water is there. So what we will, before further doing any advanced treatment, first we want to extract the water, so reducing the water content of the sludge. Now what will happen that our uh, again the water amount of the water will be high, but it will be less as compared to the initial value, and there will be some solid, and this solid will be generally organic in content. So what will happen that it will produce some kind of odor and pollution. So we have to stabilize it, the organic. So the second process is known as stabilization. So minimizing the organic content, reducing the odor and pathogens. So we will be doing some chemically, physically, yeah, biological treatment to stabilize our system. Then again, after this treatment, again what will happen, then again we will be removing more water. Okay, now because initially we have not removed all the water, and once dewatering has been done, then a huge amount of water has been removed. Okay, now so what will happen that again this will, again the sludge which is there will contain some solid. So that solid can be either be disposed or can be reused. Okay, now so depending upon our treatment, that can be either disposed in landfills or incinerated, or can be used as a agricultural, means in fertilizer or in agricultural or construction site. Okay, it's all depend upon the quality. So here is one question related to this thing only, that try to solve this question. Okay, now those who have joined now, just try to solve it, this question. I assume if miss a wastewater treatment process this much liter of wastewater per day. During primary treatment, 2% of the wastewater volume is converted into sludge. The sludge initially has a content of 4% by weight. After dewatering, the solid content of sludge increased to 25%. Then you have to calculate before some volume. You have to calculate these three things. Okay, now volume of the sludge generated per day, mass of the sludge in the mass of the solid in the sludge before dewatering, mass of the dewatered sludge after water is removed. Take your time. If you have to assume any data, you can assume. This is very simple question. Like, remember, this is I have said you that there is a system that it contains. Suppose a primary treatment was done, so this much water was coming, and whatever water was coming, 2% has been getting converted into sludge. And now in this sludge we have to remove water. Okay, now so, and it is saying that whatever the sludge is there, 4% contains 4% contain this thing solid. And here you will need density, so you can assume density is equal to 1 kg per liter. Okay, now do you know, I am considering that miss this thing sludge, miss sludge has solid, but amount of solid is very low, so that's why I'm saying that density you can consider as 1 kg per. It's not miss, I'm just for convenience I'm saying, but generally it is not 1 kg, it is generally 1.1 or 1.2. Okay, now so consider as the density as 1 kg per liter. I have given you one data, but you can assume 1.1, 1.2. It's all depend upon your uh, assumption. Calculate these three things. It's very simple question. So I am going to the solution. This is solution that you can see that volume of the sludge generated per kg is 2%. Okay, now 2% of this thing, 2% of the whatever the solid wastewater was coming. So volume of the sludge will be 1000 liter. This was very simple. The mass of the solid so here I have assumed that 1 kg per liter. The mass of the sludge equal to its volume in kg. The total of the mass sludge is this much. Okay, na. So as I have assumed that density of the sludge which is coming, it has also 1 kg per liter of density. So the mass of the solid the volume miss whatever the volume is there, the same amount of mass of the sludge will be there, that is 1000 kg per 10,000 kg, and 4% is the solid. So 4% of this will be mass of the solid. So before dewatering we have 400 kg. So now remember this 400 kg. So this was very simple. Now one thing which has to be understand. Remember, when suppose initially there was some water content, initially there was some solid content. 2% solid content is there. Means 2% solid content is there. So means x amount of solid was there and by amount of water was there. Okay, na. But when the solid percentage has increased, suppose the solid concentration has gone to 10%. Okay, na. So it will again contain some solid and some water. Okay, na. So the amount of solid which is there here, whatever the solid is here and whatever solid is here will be same, because in during dewatering process we are only removing water. Okay, na. So the amount of solid will be here also x, but the water will be by dash. Okay, na. So and there has been reduction in by, so by dash is less than by. Okay, na. By by is greater, because there has been reduction, because we are dewatering we are removing. So that's why what is happening, that solid content is increasing. Okay, na.
Okay, now.
I hope this is clear to you. So this amount of solid will always be fixed. Okay. So again the mass of we have to calculate the mass of dewater sludge. So we know that after dewatering we will be getting new sludge. We are not removing 100% of water. Remember, because we don't have that much efficiency or. Okay, na. So if the solid content is now 25%, now 25% has, it was initially 4%. You can see initially it was 4%. Sorry, 2%. Initially it was 2%, but now it is 25%. Means what has led to increase in the solid content? The reduction in the volume of water has led to the increase in the this solid content. So let m be the mass of the dewater sludge. Then mass of solid is 25% of m. Okay, now again we know that, and we know that the mass of solid will be fixed both time. That is 400 kg that we have found it from here. Okay, now. So 400 kg will be 0.025 of total volume. So from here m we can calculate is 1600 kg. So the mass, so this, so you can see that this much kg of this much kg of this much kg of uh, sludge was coming into the system, and after dewatering we have this much kg of sludge, 1600 kg of sludge. I hope this is clear to you. If anyone have any kind of doubt, you can just ask. Both of you, have you understand all person who is there? Four people are there or three people are there. Sovan and Subhas and Akash. If you have understood it, I was just explaining there is one quality of the sludge, means how much quality of the sludge you should know. Depending upon that, you will be um, designing your treatment method, and it generally depend upon how much wastewater is being treated. Then we have characteristic of sludge, that is solid, how much solid content is there, what is the density, what is the chemical composition, and all these things. Okay, na. So that will be characteristics of sludge. So if you have understood it, try to solve this question. Please solve this question. This is very easy question related to first question only. But here we have done two process. We have removed water two times. Okay na? Not two times. We have removed single times only. But there it's same question only. But one extra step you have to do. Here I have already said to you what you have to assume. You have to assume density of wet sludge and this dewater sludge as 1.1 kg and 1.2 kg per liter. See, if you won't say anything, then I will just solving. I will keep solving it. So better you should stop me where you have to understand anything, and it's very less number of people, so we can communicate in a easy way. So if anyone have any kind of doubt, please ask. I can explain. Make sure that see these question. If you are someone is preparing for gate examination and all this, it's like I don't know these type of question, but I think there has been some question related to this sludge and all this thing. So go and check. And what the basic you have to start from the basic. I think I remember in 2022 there was one question related to this uh, sludge. Hmm. That this much was I don't, 2022. Yeah, I'm pretty sure. Okay, so I'm calculating it. So first we will be calculating the mass of the sludge. So initially it is saying that initial solid content is 4%. The mass of the solid will be 4% of 8,000 kg of the sludge, that is 320 kg. Now we will be calculating the volume of the wet sludge, as it is saying that the volume of the wet sludge is 1.1. Density is already given to you as 1.1, and we know that the wet sludge is 8,000 kg, so the volume will be 7272.73 liters. I hope these two steps are very clear to you. We As we have to calculate the volume reduction, so we'll be calculating volume. Okay. Now the calculate the mass of dewatered sludge. Again, I have already said that this 320 will be fixed. So again, we have we will we will be utilizing this formula that mass of the dewatered sludge will be the mass of the solid into solid content, or the mass of the solid will be what will be the mass of solid will be always the mass of sludge into solid content. And the mass of the solid is 320 kg, that we have found it from here, and the solid content is 0.25. Then the mass of dewatered sludge will be 1280 kg. Okay, and we have assumed that density is equal to 1.2 kg per liter. So the volume of the dewatered sludge will be mass of dewatered sludge, that is this much divided by density. Then this will be volume. So initially we have this much volume of sludge. After dewater we have this much volume of sludge. Then reduction can be calculated by initial minus final divided by initial into 1000. We will be putting it. So you can see that there has been reduction of 85% in the volume of the sludge. So okay. Now if someone asks that why we are reducing the volume, can someone answer it? Why we are reducing the volume of the sludge? So it depends upon many things. The first is that we have to dispose that sludge. So if high amount of volume is there, then disposal will be very difficult. And suppose your waste is we have to convert into organic some organic manure. So the facility which is there to convert into organic manure is very small, not so means not a small, but it has some limited capacity. So you have to make sure that it meet your the amount of sludge which is going that is equivalent to whatever you have designed. These are two primary method. One another method is that generally what happens that if your this is your treatment plan, then sludge management, high chances are sludge management will be happening at some different place. So you have to carry your sludge from here to there. Now if high volume is there, then you can see that you have to go and back. Number of trucks and all these things will be in higher number. So this is not that much idea, but first two idea which I have said you that we have to handle it. So high volume means more equipment are required and all these things. Okay. Now we have reduced 85%. Again, you can imagine that in spite reducing 85%, we have this much amount of sludge. This much kg is huge. You can just imagine 1000 kg of something. Okay, now then we were discussing about sludge thickening, that they are different process. Okay, again there was one question related to this thing only, same type of question. Determine the mass of solid removed by the system each day. Same thing. Okay, now you can just take a screenshot and you can solve it on your own. Then as I was saying that different process are anaerobic digestion, aerobic digestion, lime stabilization. In lime doing we were adding one, we can add some type of chemicals. Okay, now in sludge conditioning we are also adding some chemicals, biological. Again there was one question related to lime, that how much lime we have to add. So I'm moving forward because no one is responding. Okay, now if you start solving this question, I might wait for you. You don't have to. Then here it is saying that initial solid content is 2%. Volume of the sludge is 50,000 liter. Mass of it is 2%. Then and I have assumed again the sludge which is coming has a density of 1, so the mass of solid will be 100 kg. Okay, now again I have assumed 1 kg per liter. Okay, then finally 6%. The mass of dewater will be mass of solid, and we know that mass of the solid will be fixed. So mass of solid divided by solid content, then mass of the dewater sludge will be this much. And in question it was written that mass of the density of the condition is this much. Then volume of the sludge will be mass of dewater sludge, that is this much divided by density. Then this will be volume. Okay, volume of the dewater sludge. Then we have condition sludge means dewater sludge, you can say. Then the initial volume is 5 50 liter, reduction is 60%. Then final volume will be this much liter. So this was same question but in different terms. Okay, so now lime required is 60 kg per 1000 liters, and total volume is 50 liters, so lime required will be 500 kg. I hope this is very clear to you. Then again we were discussing about disposal and all this thing. Again a simple question was there that this much water is there, 10% solid content is there. Then how much land will be required? So again 10%, 0.1, 3000 kg density. We have assumed 1 kg per liter, then 3 ton, then 50 ton of the sludge. total mass is 3 ton, then hectare will be, number of hectare will be required will be 0.2 hectare. This question I have not discussed. So I will give you some time. It is what time it is? It is 8:10. I will give you 5 minutes. I will wait till solve it. Everyone, please solve it. If you are not solving, then just tell me. I will proceed with solution. We don't have to waste time here. Anyone, both of you are solving it? Yeah, I just write in chat box that show the solution. I will go with solution. We don't have to wait for 5 minutes. Any one of you are solving it or not? Please respond. Please proceed. Okay. So you can see the question that a wastewater treatment plant is considering upgrading its sludge dewatering system. Currently, the plant generates this much liter of sludge daily with 2% of solid content. This at this point it is similar to what we have discussed in the previous question. The new system will increase the solid content to 7%, but also increase the operational cost by 0.05 liter of the dewater sludge. If the new system can handle the sludge efficiently and reduce the final volume by 65%, calculate the additional cost per day due to upgrade. So initially some amount was there, finally there is some amount. We have to see that. Okay now. So again here I have assumed the density as 1 gram per kg, 1 kg per 1 kg per liter. Okay now. So initially 2% solid was there. So volume of the sludge this much. The mass of the solid will be this much kg. Okay now here mass is I have written it incorrectly. It will be liters only. Okay now. Finally we have debutter sludge using the final this. Now we know that this much of solid will be always fixed, and the final solid content is 7%. That is after this thing. Okay now. Finally we have 7%. Okay, so the mass of the solid will be this much divided by 0.07, then mass of the dewater sludge is this much kg. Okay, so in the question it is written that the dewatering process reduced the volume by 65%, that the final volume will be 35% of the initial volume, and in initial volume we have 90 liters. Okay now, so the final volume will be 0.35 into 90,000 liters, that is final volume is equal to 31500 liters. Okay now. So additional cost per liter is how much? 0.05. Remember here what we have used. We have used the concept of this 18. We have assumed the concept that within after by dewatering, one thing which is fixed is our mass of the solid. So this mass of solid, we have used the concept of that thing. Whenever we are dewatering, when we are increasing our solid content, we are reducing our solid content, mass of the solid is fixed. Only the volume of water is changing. Due to that, there will be increase or decrease in solid content. So again, the final volume will be 31500 liter. So you can see that additional per liter is cost is 0.05. So cost per liter will be how much additional cost will be there into final volume. So this much. So additional cost will be 1575. So to upgrade to the new sludge rebutting system will result in additional operational cost of 1575 per day. I hope this is clear to you. So these were some of the few concepts which I have discussed today. So now we have again same question which is being asked to you in assignment. So try to answer it ABC multiple choice question. Okay na. So I request everyone to please write in chat box what will be the answer of this question. See, if you do not ask any specific question, I will be doing this thing only. So if you want that I should discuss any specific thing, just tell, say me. Suitable inorganic and organic remove from the are components of. So we will be looking one by one. In wastewater, three type of sludge are generated. Various are as follows. At a screening chamber, there are material like plastic, paper, rags removed from the raw wastewater through the screen at primary preliminary treatment of they are not considered sludge. Okay. Okay. One has left the material. Yes, the current is PMRF only. Sludge.
हे बघा ते कसं दिसतंय बाबा माझा हातात
Hmm. The sludge is formed during the primary treatment of the wastewater. In this case, suitable and organic organisms are removed from the wastewater in gravity primary sedimentation time. Primary sludge contains high concentration of suspended solid and organic matter that settles out in the wastewater. Then we have secondary sludge, also known as activated sludge. This is primarily due to secondary treatment where microorganisms break down organic matter. It includes both microorganism and organic. Thus, they consume secondary treatment are less dense than primary sludge and contain significantly amount of biological matters. So this won't be my answer. Okay, because we are talking about inorganic and organic both. Then finally we have digested sludge. This is sludge that is undergone digestion, a process where microorganisms further decompose the organic matter into sludge. Digestion reduces the volume of the organic and its organic content, producing a more stabilized and less orders in product. Okay now. So this B will be our correct answer. Thus, settleable inorganic and organic solids removed from the raw wastewater are primary component of primary sludge. Coming to the second question, the sludge produced from the secondary clarifier of conventional STP is known as. Okay. screen and they are material removed during the primary preliminary treatment. Screening include large debris like plastic and paper, while grit consist of inorganic material like sand and gravel. These are not produced in secondary clarifier. The primary sludge, this sludge is generated during the primary treatment stage where the suitable solids are removed from the raw material. It is difficult from the solid produced in the secondary. So we have already know this thing, we already discussed this thing. Then finally we have digested sludge. This is sludge that has undergone anaerobic. We have already discussed all these things. Then we have this waste activated sludge. This sludge is produced from the secondary clarifier as result of biological treatment. We have discussed. We have in big six. We have discussed these things. It consists of the excessive biomass generated by microorganism during the secondary treatment, which is then removed and required further processing and disposal. Okay, now. So yes, you are correct that. From STP sewage treatment plant we have this waste activated sludge. Okay, now so this D will be our correct answer. Okay, try to answer this question. Match the following process treatment given in the first column with their specific objective given in the second column. First we have sludge thickening, then we have sludge digestion, then we have sludge hygienisation. We have discussed it. A sludge thickening will be reducing path. A D have miss first का A sludge thickening is reducing the I don't think. See, A will be matching with so this this will be match hygienisation. When we are when we are talking about hygienisation, we are reducing pathogenic bacteria. So third will be matching with A. Let me see what is the answer. Huh. Our answer will be, we have to see just only, our answer will be B. Not, I don't know why you have said D. Thickening means we have to we are removing water. Okay, so that's why thickening means digestion means we are reducing our organic content, and then we when we are talking about hygienisation, we are removing pathogens. I don't know why you have said D. Any comment why you have said D? D won't be the answer. B will be answer. Why you are saying D? See, just remember different process. Thickening is sludge thickening means we are removing water. We are thickening means our initially a huge amount of water will be there, so we have to make it thicker. So what is the process? We have to remove water. So that's why first will be matching with reducing water content. So first will be matching with B. So either answer will be A or B. Then we have sludge digestion. When we are talking about digestion, we are talking about conversion of organic matter. Remember anaerobic digestion and all these things. What we were doing, we were converting C into, we were converting C there we C4 C6 something kind of that kind of material were there, and we were converting into simpler compound like CO2 and methane. So this will be digestion will be, this will be matching with C. And hygiene means when we are talking about hygiene, what we are, hygienisation is related to pathogen. Yes, you are correct. Hygienisation means hygiene means we are, when we are, when we are using hygiene, then we are concerned about pathogen or bacteria and all these things. Okay, na. So here you can see also this sludge thing. Aimed at reducing the water content in the sludge. By concentrating the sludge, it become easier to handle. Thus, the objective is B. This involves breakdown of organic matter into sludge microorganisms. The primary goal is to reduce organic content and stabilize the sludge. Thus, the answer is C. Finally, sludge. This is to reduce the pathogenic bacteria in the sludge to make it safer for disposal or reuse. We don't want to throw our sludge which contains high amount of bacteria and all these things. I hope this is okay to you. I hope you have understood it. Increasing the solid content. Remember, they are talking about increasing the solid content of the sludge through mechanical or gravity thickeners leads to. This is a very simple question. Sludge thickening. The process of thickening involves increasing the solid content by removing the water content. Mechanically or gravity thickener achieved by separating the water from this. Okay, now. So, so the thickening. So you means you can say that when we are thickening it, we are just reducing water content. Okay, now. So overall volume of the sludge will increase. So the answer is decrease in the total volume. That is this C answer is there. Okay, now. So you can see the mechanical thicker they are used to mechanically by rotating drums and all these things. Gravity thickness we have. Then impact of volume decrease in total volume as the water is removed. The volume occupied by the sludge decreases because the remaining sludge has higher concentration of solid. The overall volume of sludge reduce the water content. I hope this is clear to you. C, yeah, C is correct answer. Good. Which of the following are example of mechanical sludge thickening system? Mechanical. D. Yes, correct answer is D. Yes, all the listed system are example of mechanical sludge thickening system. So, filter press uses a series of filter plates. Just if you want to see how they look, just type on Google. You will look at image. I am just giving you some normal definition, but it's always good to visualize the thing. Once you visualize the things, if once you have seen on internet, you will be okay. You can just imagine also that how these things are working. Okay, in process of anaerobic sludge digestion the organic, this is related to previous big question. Okay, now if you have attended previous lectures, just try to answer it. In the process of anaerobic sludge digestion organic matter is converted to, if you have attended my session, I have given in deep, i have I have explained this thing in very deep, in details, how things are getting converted, how carbon and all these things. Please answer this question. In the process of anaerobic digestion, an organic matter is converted to. So we will be seeing this thing. So in aerobic sludge digestion, several key biological reaction occur. Here are the primary. So we know that there are four processes, and then we have bacterial growth also. So first will be hydrolysis. Such as complex organic matter is broken down into simpler compound. Complex organic matter will be there. It will break into simple sugar plus amino acid plus fatty acid. That is, if sucrose is there, which is known which is very complex, then it will be broken into glucose and some other forms. Okay. Then we have acidogenesis, means formation of acid. Simple compounds are converted into volatile fatty acid, hydrogen, carbon dioxide, and other byproduct by acidogenic bacteria. Simple sugar, which was here, so initially it was here. So again, what will happen that this will be converted into some acetic acid and some kind of other acid also. means different kind of acid along with hydrogen and CO2. Yes, you have given D. Then we have acetogenesis, that is formation of acetone. Volatile fatty acid and alcohol are converted into acetic acid, hydrogen, and carbon dioxide. So again, what will happen that all the acid which is there, and will be getting converted into acetic acid with another bacteria. Okay, and finally, what will happen that this bacteria will be converted into methane. Okay, now, and along with whatever the energy, what will happen that micro and we have known that meanwhile the microorganism also consume our food and their population growth. So what will happen that, and by doing so they produce some kind of energy, and those energy are used to production of new cells. Okay, now, so these are some part is used as food, some part is used as a production. Okay, so their population also grow. So you know that with time what will happen that the amount of food will decrease, but the bacterial growth will be increasing like this. Okay, so we have seen this is for bacteria and this is for food. Okay, now, okay, so those reactions collectively transform the organic bacteria into simple compound including methane, carbon dioxide, and new bacteria. So answer will be D. Yes, correct answer will be this D, all of above. Okay, I hope this is clear to you. Coming to the question number 7, the sludge digestion process usually leads to. This is similar to the question number 5. Sludge digestion process usually leads to less water content in sludge, less total mass of the solid, higher total mass of the solid. Digestion process does not alter liquid. This is very simple question. If you have gone through digestion and if you have listened to the my numerical problem which we were discussing, you can answer it. Okay. So in sludge digestion, both liquid and solid are affected. Less water content in sludge. This process typically reduces the water content in sludge, but is not primarily affected. Is not observed. Okay. The in the sludge during digestion, microorganisms break down the organic, which leads to reduction in the total mass of the organic matter is converted into gases and new microbial biomass resulting in the rate reduction of. Okay, now. So So I hope this is means this was also a very direct question. This is not correct as the digestion process generally reduce the total mass of the process. Here remember we are talking about digestion. Digestion means what is digestion? Digestion means we are digesting organic matter. So if we are digesting organic matter, it's simple. Uh, the mass of the organic matter will decrease. Okay, na. So the correct answer is B. Please participate. I don't know why you are not participating. The higher total mass of the sludge. This is not correct as the digestion process generally reduces the digestion. This is also incorrect. Digestion process alter both liquid, but the amount of the liquid which is altered is very less. Okay, so the correct outcome is total mass in decrease in the total mass. The total mass of the solid in the sludge. Question number 8. Coagulant such as ferric chloride, alum, or organic polymers may added to wastewater sludge for sludge stabilizing, sludge thickening. Remember the process, and then you will be able to answer this question. What is sludge stabilization? What is sludge thickening? What is sludge conditioning? What is sludge hygienisation? So the correct answer is sludge conditioning. Coagulants such as, because we have already discussed what is sludge stabilization, so I have not rewritten it. No, I have written it. So coagulants such as ferric chloride, alum, or organic polymers are typically added to the wastewater sludge for sludge conditioning purpose. The primary purpose of adding coagulant is to condition the sludge. Conditioning improves the dewatering characteristics of sludge, making it easier to separate from water from solid during the dewatering process. Remember, we want to remove our solid and all these things. So for that, we add some kind of chemical. So what happened that they agglomerate and they form some kind of flocculants and all these things, and they can be easily removed. Okay, now so for that we use this kind of salt, that is ferric chloride, alum, or organic polymer. Mechanism coagulants works by destabilizing the the particles in the sludge, promoting the flocculation and enhancing the aggregation of sludge particles. This leads to better removal. Now remember how this mechanism. So now suppose if you have sludge and all the solids are randomly distributed, and if suppose if you are passing it through, so there will be reduction in solid, but re- now imagine that there is another process where you have added some chemicals and those sludge has formed some kind of lumps. Okay, now so which one will be easy to remove? Obviously this one will be easy to remove. So that this process is known as conditioning, sludge conditioning, that we are adding something, they are forming some kind of flocks and all these things, and that can be removed easily. Okay, we have already discussed what is this sludge stabilization. Involves processes that reduce the potential for odors and, and stabilize the organic matter after through. We have already thickening refers to the reduction of water. We have already seen that refers to increasing solid content. Remember, we are increasing the solid content. The amount of solid is fixed. If we are increasing the solid content, what is decreasing? We are decreasing the volume. That is, we are removing the water. Okay. Then we have sludge hygienisation, involves the process aimed at reducing pathogens in the sludge to make it safe for disposal or reuse. Okay. Therefore, the coagulants are specifically used to sludge conditioning to enhance the sludge dewatering properties. Final, we have 9 number question. Sludge drying beds are one of the simplest method of dewatering, but they have larger land footprint. Dewater sludge essentially have zero or near zero water content. Remember, no sludge has zero water content. So obviously, this statement is incorrect. So my answer will be either A or B. Sorry, either A or D. So now just you have to think that whether statement one is correct or not. Oh, you have answered A. Okay, so I will be moving forward. So yes, correct answer is A. We have to know the region. Okay, na. The sludge drying beds are one of the simplest method of dewatering, but they have large. The correct. The sludge drying beds are indeed simple and low cost method for dewatering. However, they require a large area of land due to need of extensive surface area. So just I will show you how big it is. You can just so you can see that this much big amount of sludge drying bed they require, so a huge amount of land is required. Here you can also see. Okay, now so these are general sludge drying bed. Okay, now so that's why a huge amount of area is required. Okay, so yes, a statement one was correct, but a statement two is incorrect. Remember, no sludge has zero water content. Dewater sludge is essentially have zero on this incorrect. Dewater sludge does not have. even after dewatering, some water remains in the sludge. The goal of dewatering is to reduce that water significantly, but it's not possible to completely eliminate all the moisture. Typically, dewater sludge has a moisture content ranging for 20 to 80%. Generally, it is on higher range only. It is around 80% only. Okay, now. So yes, A was our correct answer. Coming to the question number 10. Identify the appropriate option for the use of wastewater sludge. Sludge can be used to produce bioenergy. Digested sludge can be used as a compost slash fertilizer. Use of incinerated sludge as building material or all of these. So each option listed represent a viable method for reuse. So each option is a thing. Each option is will be there for reuse. Sludge can be used to produce bioenergy. Correct. Sludge, particularly from anaerobic, can be used for production of bioenergy in the form of this bio can be utilized for energy generation. Digested sludge can be used as compost slash fertilizer. Correct. After digestion, sludge can be treated further to produce compost or fertilizer. The treated sludge, rich in nutrients, can be used to improve soil. This yes, this is also the correct answer for this is D. Okay, now all of above. Yes, you have right. Ash from the incinerated sludge can be used as a raw material in construction sites such as production of bricks, cement, or concrete. This helps in recycling the ash and reducing the environmental impact. Thus, all the listed options are appropriate. Sir, can you upload the exercise? Yes, this yes, it will be uploaded. I think you guys, miss, everyone is receiving one mail from this. NPTL now where this the recording of this session, the PDF of this discussion is all is all given to you. Yes, if you are registered on NPTL course, of course you are registered. That's why you are here. Just check your email ID. Let me see how. Just let me check how it will be. This kind of chart has been given to you now. Are you guys getting this kind of chart? I don't remember the link. I don't have link now. But here you can see all the PPT. Here you can see that all the PPTs are uploaded till week 6. This is for my part. There are two other T also. They are also uploading each and everything. So I request you to please go through that mail. Oh, you are saying yes. Okay, then what's the problem? Okay, we have question number 11. A water content of itna kg per day wet sludge reduced from itna to 90 using a sludge. What is the net change in the total quantity of dry solid present in the sludge through this thickening process? This is very simple question. They are talking about net change in the total quantity of dry solid. Remember, theoretically what I've said, dry solid. Try to answer is what is the net change in the total quantity of dry solid. It should not take any time. I have already discussed so much numerical question today. See, to determine the, I'm going to see this was theoretical question, not a numerical question, but still I am trying to answer it. To determine the net change in the to calculate, see, initially this much amount of water was, finally this much water content was there. So what will happen that if you initial water content is uh, so dry solid will be 1.5%, dry solid will be, so you don't have to just see I am giving this much, but remember the amount of solid never changes. The answer will be 0%, but I am showing how this 0% is coming. Okay na? So you can say this W is always fixed. Okay na? This W is always fixed. Sorry, not W, this dry solid, the weight of dry solid is always fixed. Okay na? So here, from here we can see that dry solid is a weight sludge into fraction of solid, that is 96 kg, and this 96 kg is always fixed. This 90, there won't be any change in 96 kg, because we are removing only water, not any solid, during sludge, during dewatering. So you can see the net change is 0%. The correct answer will be A. Just for sake of convenience, I have shown you these things, but these are not needed. By seeing this question, as they are saying the total quantity of dry, there only you could have marked answer A. Okay, now coming to the question number. Oh, I forget to write down the question number 12. Just 1 minute. Give me one moment. 1 minute. Just 1 minute. Okay, so this is our. We have only 10 minutes left, so I will. So there is one this question. A thickened sludge is having a ratio of volatile to total solid as 0.75. So there is something called volatile solid. Why it is larger? Hmm. So we have volatile solid that can be easily. How to define volatile? Volatile means that can be easily converted into gaseous form. Okay, now by some heat process, and so those are known as volatile solid. The ratio of volatile to total solid is 0.75. The sludge is further digested where 72% of organic compound, generally organic compound or compounds are volatile. So what will happen that if you give a small amount of heat, it will evaporate. Okay, now generally C will be converting into CO2. Neglecting any, remember, but there is to find the this not miss the see if you study this total solid chapter from a book, the temperature required for converting this volatile solid, to find the volatile solid we use a temperature of 600 degrees Celsius. Okay, now so I'm just definition is that which can be easily converted into solid, but the temperature required is around 600. Okay, now remember this thing. Don't get confused. Neglecting any loss in inorganic fraction of the solid, the total Vs by Ts of the digested sludge. Okay, and after 75% conversion, what will be the ratio of digested sludge? So we will be looking it here. So volatile solid is undigested solid. Volatile solid is 0.75 into total solid that is given to you. So non-volatile solid will be 1 minus 0.75 into total solid, that is 0.25 total solid. And this non-volatile will be remaining in our system, will remain in our system. 72% are to loss or 28% are remaining. So remaining volatile solid will be 0.27 into 0.75 of total solid. So remaining is 0.21 of total solid. Okay, this is very simple. So total solid is non-volatile solid plus remaining solid, that is 0.27 into total solid plus 0.21 plus total solid, that is 0.46 total solids. So we have to find the new ratio. The new ratio will be whatever the volatile solid is there, that is volatile solid 0.21. Okay, 0.21 total, that is this remaining 0.21, and by total ratio, that is 0.46 total. So the ratio will be around 0.68. This was very not miss, I can say simple question, just you have to do some kind of manipulation from here and there. Okay, I hope this is clear to you. Again, a question related to what I have already discussed, but still I am going through it. A secondary clarifier of ASP activated sludge process, this produces this much amount of wet sludge containing 1.8% weight by weight solid content. The sludge is thickened to increase the solid content to 5%. The thickened sludge has a specific gravity of 1.9. The solid fraction is 80% and organic 80% organic, 20% inorganic. The thickened sludge is further processed in an anaerobic digester, and the final amount of the dry solid after digested is 240 kg per day. Based on the information, answer the following question. The total amount of dry solids in the thickened sludge. So this is very simple. That wet sludge is this much. This is already given to you, 37 kg per day. 1.8% is solid content. So dry initial dry will be 666 kg per day. Okay. So this is our answer. They are asking that total dry solids is so 666 kg per day. The amount of dry solid in the thickened kg is 5%. We need to find the final. This is second part. Okay, now so this is so this is second part, that is total volume of the sludge produced after sludge thickening in meter cube per day. So this is this after we know that after thickening is 66 kg per day and the solid content is 5% weight by weight, and the density is already given to you as 1.1. So as a dry solid represents 5 kg of the total weight, so total weight will be whatever the dry solid divided by 0.05, that is means this much of total sludge is being produced. So this is our total sludge. Okay, total sludge, and the specific gravity is given to you, that is 1.2 kg. So we can convert it into our specified unit, and we can find out the volume. The volume will be total weight of the thickened sludge divided by density, that is around 12 meter cube per day. This was also very simple. We have assumed that concept only, that total weight of the solid is fixed. Okay, in spite the solid content had increased, but the weight of the solid is constant. That's why we have divided by that content. Okay, so finally we have 12 meter cube per day. Assuming no reduction in inorganic fraction of solid during digestion, the percentage of reduction of organic content in the solid during the digestion is. So again, this is like a bit lengthy part, but again we can solve it. Okay now. So here initial this much 80% was organic, 20% was inorganic. Final amount of the digestion is 240 kg per day. Okay now. So organic is 533 kg because it is 80%. Okay, and inorganic solid is this much, that is 133. Total will be 666 kg. Okay, so final inorganic content will be remain unchanged, that is 133 kg. The final organic content will be total final dry solid minus final inorganic. So final dry we have 240 and 133 is inorganic. So it will be 107 kg will be our organic content. So reduction will be initial minus final. So 533 was initial, final is 106, means this much has been reduced. So percentage will be total, that is 533 initial or organic content, how much initially was 533, and reduction will be 426, so around 80% has reduced. So this was also very question. This question and question number 12 was similar question. We are so this was last question. If you have any doubt, you can ask right now. uh, any doubt?
For additional practice,
No,
which
no, just sorry. uh,
for
for
additional, hello, sir.
huh,
For additional practice, the examples available in the any book.
yes, you can refer to Metcalf and Ed, this book.
Acha.
And there is one another book, this wastewater uh, water treatment by SK Garg. Here also you will be finding some miss good examples. This book, wastewater treatment, sewage disposal, and you will find this is in wastewater sewage disposal and all this thing, you will be finding this book, wastewater supply and wastewater engineering. No, this notebook, this by SK Garg, just refer to SK Garg. Or you can also Matt and ED, 5th edition. Refer to this book also, wastewater engineering treatment. Here also you will be finding some, these two books I am suggesting.
Okay, sir. Thank you.
Okay. Any more doubt? Any more question? Okay, so I am ending this lecture. So please meet in next session, that is on next Tuesday. Next Tuesday we have 17th, 24. Tata.